Yes. So, Srikal students, today we are going to discuss about coefficient of variance known as CV. You see, students, we have already studied the measures of dispersion, the mean deviation and standard deviation. You know, now they have same units, whatever is there in the data. Like we want to compare the variability of two different series with same mean, which are measured in different units. So we don't merely calculate the measures of dispersion, but we require such measures which are independent of units. So what is that measure of dispersion which is independent of units, so that we don't get confused with different units, you know, that measure of dispersion is coefficient of variation. So how do we define coefficient of variance, students? It is a measure of variability. I would write here. It's a measure of variability which is independent of units, which does not depend upon units, is known as coefficient of variance. It's denoted by CV. Now, what is the formula for calculating CV? Student, CV is equal to standard deviation divided by mean into 100. Obviously, x bar should not be equal to 0. The denominator should not be equal to 0, making the whole term invalid or error. So students, now we can take an example. Like for example, we have one series, like you see 6, 8, 10, 12, right? If we take different series, 6, 8, here we are taking same units, 6, 8, 10, 12, 14, and here 4. Obviously students, you see both of them will have same mean. Now what will be the mean? You see this mean would be 8 plus 12, 20, 30, 36 divided by 4, and so that is equal to 18 divided by 2, well, that is equal to 9, right? Okay, so here it is, you see 20, 30, 44, 44 plus 6 is 54, right, divided by 6, so that is again 9. Here the mean is same. Okay, we have taken this example with same units. We can take example with different units also, right? Here they can be marks 4 students, marks of 6 students, but you can take an example with different units also. Okay, so well, the mean is same, but you see the variability in this data is more, the variability in this data is less. So coefficient of mean, coefficient of variance is a right way to understand uh, in both the cases. Number one, when the unit is different, where the variations are more. Obviously, we know variations are more in this case as compared to this case. So we will find CV, in both the cases. Wherever the CV is more, so that data would be considered to be having more variation. So let's calculate CV for both the cases. So students, for that we need to calculate, uh, as the formula for CV is uh, standard deviation divided by mean into 100. So we need to calculate standard deviation of this data, standard deviation of this data. Well, standard deviation is equal to under root of variance, and variance is 1 by n, the mean of summation of xi minus x bar whole square, right students? So this will be, total terms are, total frequency is 4, 1 by 4. If I want to calculate the summation of xi minus x bar whole square, it will be 6 minus 9 whole square, so that will be 9 plus 8 minus 9 whole square, 1, again 1 plus 9. So that is equal to 9, 9, 18, 20 divided by 4, right? Obviously, mm, it will be under root of this, under root of this, under root. So it is 5 under root, right? But here the standard deviation again would be, first we'll calculate variance. So that will be 1 by n. Obviously the n is 1, 2, 3, 4, 5, 6. 6 terms, right? And then we will add all the variations. So what is the first variation? 4 minus 9 whole square, that is 25. Right? You see, 4 minus 9 whole square. So that is equal to minus 5 whole square is equal to 25, right? Plus 6 minus 9 whole square, 9. 10 minus 9 whole square, 1. Plus, uh, see, 8 minus 9 is again 1. And 10 minus 9 is again 1. Then 12 minus 9 is again 9 plus 25. Right, so this will be equal to 25 plus 25 is 50, 50, then 68, 70. So it will be 70 divided by 6. Am I right? Hope I'm right. Here it is, once again, 50, 68, 70, correct, 70 by 6. So the standard deviation in this case would be 70 divided by 6 under root, that is equal to under root, let's say 11 point something. Let's say 11.6, right? Okay, so obviously the, you see students, the standard deviation of this data is more as compared to standard deviation of this data. So if I want to calculate the coefficient of variance, right? So coefficient of variance for this data, CV2, would be sigma 2 divided by x bar 2 into 100, right? So this will be sigma 2 is 11.6 under root divided by mean is same in both the cases, right? The mean is 9. 9 into 100. And in this case, the standard deviation sigma 1 would be under root 5. That is the standard deviation. I've written it wrong. It will be CV1, coefficient of variance in case of 1. And this is coefficient of variance in case of second data would be equal to sigma 2 divided by x bar 2 into 100. So it will be, what is x bar 2 is again 9 into 100. So clearly we can see students that this, this now this value is more than this value. So hence we can say the variations are more in this case. Now this looks pretty simple because somebody can say, well, just by looking at it, I can see the variations are more. So why I need to go to coefficient of variance? But it's really helpful when the units are different. Okay, so now we can do some numerical also. Yes, students, we have this numerical. Two plants A and B of the same factory show different results about the number of workers and wages paid to them, means salary paid to them, or maybe per day, whatever it is, the money paid to them. Number of workers in A is 5,000, B is 6,000, right? Average monthly wages are 2,500 in A and 2,500 in B. See, here you can say average monthly, average indicates the mean. The mean is same in both the cases, right? Then variance of distribution of wages, here it is 81 and here it is 100. So it says in which plant A or B, there greater variability in individual wages. So, students, so again, coefficient of variance helps us to understand this, right? So we know that, coefficient of variance is equal to what? Standard deviation divided by mean into 100. So it's expressed in percentage, right? So, it doesn't have a unit, coefficient of variance is independent of units. So now students, you see that uh, for A, if you want to calculate CV, here mean is same. So obviously the CV of B would be more. Reason behind the variance of uh, the B is more. So when variance of B is more, this variance means sigma square. So obviously CV1 would be 81 under root, that is 9 divided by 2500, right? So into 100, and CV2 would be 100 under root, right? Because this is variance, so standard deviation is 100 under root is 10. So divided by, again, main is same, 2500 into 100. So we can clearly see that CV2 is more than CV1. So we can easily conclude what? That Plan B has greater variability in the individual wages. Right, students? Don't forget to subscribe the channel. Have a nice time.